All right, so now it's time to wrap up chapter 2. We finished 2A earlier. Um, Now we're going to look at chapter 2B. Chapter 2 is cut up into two pieces. And so chapter 2 is different from chapter 2A because here we're going to focus our attention on comparison of two different variables to each other. Okay, so in many applications, we are looking at individual variables, but it's often important to understand how these variables are related to each other. Okay, so that's what we'll be doing here. Now, of course, we will want to be able to organize the data and express it in a very convenient way. So we can create a special type of table called a cross tabulation. And we also have special graphs that are intended for cases when we are looking at two different variables. So now I posted in Blackboard, this one is chapter 2 restaurants. And what's happened here is that the data consists of 300 restaurants. Let's scroll down for a second. And you can see that there's only two variables here. One of them is the rating of the restaurant, which is, of course, qualitative data or categorical data, it's sometimes called. And then the second number here is the price, the average price of a meal in dollars. So that's, of course, quantitative data. So in the slides, they have set up the data to look like this. Although I just noticed that they've got excellent on the bottom and I've got excellent on top, but all right, but it's the same idea. You can see just by looking that we have the three ratings, and across the top we have different ranges of prices. You can think of these as classes. The meal price averages 10 to 19, 20 to 29, 30 to 39, and 40 to 49. And so it's kind of instructive to look here and see what kind of ratings we can get depending on the different prices. So you can see, for example, there's only two times when we had an excellent meal in the $10 to $19 range. So it kind of makes sense because you would imagine that at a relatively inexpensive restaurant, maybe the quality is not quite what it would be at a more expensive restaurant, although it doesn't always work out that way. So you can see that there does seem to be some kind of connection between the prices and the ratings. So this table is set up so that we can visually see what this connection looks like. And then we have all the totals. So this is an example of a cross tabulation. And what we can do is convert these into percentages, of course, if there's some reason for it. And so in other words, what they're doing here is they've taken this information. In fact, here's what we could do. We could do it right now. But what you would have to do is this. For this one, for example, you put equals this number divided by this number. And then you would drag it across. And then, whoops. Okay, you see what I did there? I forgot to put in the dollar signs. It's so easy to do that. Actually, that was a very illustrative example of why you have to have dollar signs, because if you notice, that K2 will be the denominator for all of these numbers in this first row. So that K2 needs the dollar signs. And now it should work. All right. And then here we'll do the same thing. So I'm going to have K3, which will require dollar signs because I'm trying to figure out the percentage within each row. Okay. All right, and then I'll do this one as well. This value divided by K4, which is over here, and drag it across. And so the grand totals aren't terribly meaningful at the way it's set up. It just means 100%. And then this one should be replaced with, well, actually, these sums are not really very meaningful either. So I'm just going to delete this last row because it doesn't tell us a whole lot. So now you've noticed how we've got our percentages. It doesn't look very pretty, does it? So I'm going to select these numbers. Actually, I might as well select them all. And I'm going to come up here. You see this percentage sign? If I click it on, now all of a sudden, this is exactly what I was looking for. So I can easily see that, for example, within the excellent category, 33% occur within the $40 to $49 range. And then you can do the same thing for all the others. And whatever information we're trying to get, it's easy to see it at a glance by looking at this cross tabulation. All right. So now the next thing we're going to do is plot this the relationship between two variables. I don't think we're going to do it with this data. We have another spreadsheet in here, which is called electronics. Yeah, that's the one. Okay. So you can see here, this one refers to an electronics store. And they're trying to find out at this store if there's a connection between their sales volume and the number of commercials that they've run on TV. Because, you know, they spend a lot of money in these commercials. They have to know if they're helping sell products. So how would you do that? Well, one way you could do that is to plot out a graph of these two variables. And so here we can assume that the sales volume depends on the number of commercials. So we'll think of the sales volume as the X or independent variable. And the number of commercials is the, oh, sorry. I'm sorry, I got that backwards. X is the number of commercials because that's a choice variable. The sales volume responds to the number of commercials. That's better. Now we're talking. Okay. In other words, we choose the number of commercials. This is the resulting sales volume. So we're going to use a very special type of graph here to illustrate this relationship. So even before we see it in the slides, I'll show to you what it looks like here. We're going to go and choose these two columns. And then we're going to insert. Let's look at the recommended charts first. Yeah, oh, there it is. They have it. Okay. So what you're seeing here is a special type of graph, which is known as a scatter plot. Each one of these points represents a single observation from our data set. In other words, each point is 1 week's worth of data. I think you can tell which one is which if you click these on. There's a way, if you say, yeah, here we go. No, I guess that's not what I wanted. But you should be able to tell by looking at these which point is which. So yeah, I don't remember how to do it, but technically you can ask it to show you the value of X and Y for each of these points. Now this one, actually, oh no, it's doing it automatically by hovering over it. You can see that this one, for example, refers to it says 2,50. That must be this point right here then, because X is 2, Y is 50. Over here, 354, that would be this point. Okay. In other words, that's week 4. So in other words, each one of these points is a single observation on the number of commercials and on the sales volume. Now, oh, and one more thing. I'm going to show you how to label the axes. In a graph like this, it's kind of important to know which variable is which. So in order to label the axes, what you can do is select the graph and go to, actually, no, chart design won't do that. If you right click, No, maybe it is chart design. There it is. Okay, I was right the first time. It's you just chart design, add chart element over here on the far left. And I'm going to ask it for axis titles. So we'll start with the horizontal title, and I'm going to type commercials. I'll put an X there to remind everyone this is the independent variable. And then I'll click on the graph again. And by the way, this part could be different on the Mac. This is one area where they might actually be different, but it can't be too different. You should be able to figure it out if you're using a Mac. If not, you probably should be able to find the instructions on the internet somewhere. There's got to be a website somewhere that is set up to explain to you how to use Microsoft Excel on the Mac. I'm sure it's out there somewhere. And if not, there are YouTube videos all over the place that I'm sure one of them has this all set up. So anyway, let's once again choose here to chart design. This time I'm going to ask for the vertical. Whoops. All right, I blew it. There we go. I want the vertical axis title. Now here's an interesting result. You're going to actually be typing uphill, but it works. And you'll call that sales volume Y. So this way, it's clear to anyone looking at this graph what exactly is going on. It's a scatter plot that shows the relationship between the number of commercials that we run every week and the resulting sales volume. How does this help us? Well, among other things, it helps us visualize if there is a connection between the two variables. So now I'm going to introduce what's called a trend line to this graph. And the trend line is a line that gets as close as possible to all these points. If I right click, add trend line, well, that was easy. There it is. And now here's what we're after. The slope of the trend line is positive, which means that as the number of commercials increases, there is a tendency for the sales volume to increase as well. Now, that's a good starting point. It's not enough. We'll see later on. What we really would ideally like to know is every time I run a new commercial, how many dollars does that add to my sales volume? We will do that at another time. But for now, it's enough to note that it's pretty clear that as we keep increasing the number of commercials, we're also increasing the sales volume. Now, of course, what remains to be determined is how much extra revenue am I getting and how much am I paying for these commercials. But right now, we do know that more commercials leads typically to more sales volume. All right, so this is our scatter plot. Now, here, if you notice, this is what, of course, this is a positive relationship. You can tell because the trend line is a positive slope. For some cases, though, the variables might be going in opposite directions. Like for that electronics store, what if the X variable wasn't commercials, but the number of holidays in that month or something like that? Well, clearly, the more holidays, the more time the store is closed and the lower our sales could be. And then sometimes you have a case where the two variables are just plain not related to each other at all. Like here, for example, if I replaced the number of commercials with the number of days that it rains, well, it's not likely that the sales of the store are being affected by the rain. So those two variables would not be related to each other. And then you would get a trend line, which is basically flat. All right. So yeah, so here's this is what we just did right here. All right. They are explaining to you how to get a scatter plot in Excel, which is good. And now they also went back and revisited the restaurants to create a special type of bar chart where you're comparing two different things at once. In other words, for each price range, the three bars represent the three different ratings. So in order to do that, um, let's see, let's go back to the data for a second. I think if we just select the data like this, let's find out. Let's just go to the recommended charts. No, there it is. It's pretty smart. Now, of course, we can change the colors if we want. Those are kind of bizarre, but if you notice at the bottom, it tells you what each one represents. Blue is excellent, red is very good, green is good. And so the prices are listed here, and you can see the relationship among the cheaper restaurants at the far left. The majority of the reviews are very good. Down here in the far right, at the expensive restaurants, we tend to get more excellent reviews. Okay. And you like to think so because you're spending so much money. So we can change the chart title to prices versus, let's say, ratings or something like that. And so you can see at a glance what's going on here. Now, they're also mentioning the stacked bar chart, which, the colors determine within each bar what how many people fall into each category. Let's see if we can do that one. So let's go over here to this bar charts. Oh, I'm not so sure if it has that one. It's got a lot of them, but I don't see that one. Some of them are pretty cool. They're actually three-dimensional. Boy, I guess maybe they don't have that. Right. Anyway, it's not that important. I mean, I think this is the more normal way to do it, but so here they're sort of comparing the different types of charts, trying to help you understand when you might use each one. Sometimes you have them all together in one place. Again, I don't think Excel can do this, but all right. So that's enough for chapter 2. I think we're good because chapter 3 is an incredibly important chapter. This is where we might need to use the calculators as well as Excel. What we're going to actually do now is move away from graphs, and we're going to focus our analysis on numerical measures that describe the key properties of a set of data. Now, this is where most of statistical analysis takes place. So the graphs are important, but what we're about to do is by far the most important part of statistics. In other words, creating measures that help us understand the properties of our data. Now, many of these you may have heard of before. It's entirely possible that you ran into some of these concepts in high school, or you just heard about them somehow. But we'll see as we go along. So we're going to start by introducing numerical measures. By the way, this is referred to often as descriptive statistics, which means that we are basically displaying for people to see the key properties of a set of data. And then inferential statistics is where we draw conclusions from that data. Okay, so this is descriptive statistics, but it's very quantitative because we're going to do a lot of calculations. And you can see there are two basic measures that we will be considering: measures of location, which essentially is an attempt to find out where's the center of your data, and measures of variability, which are an attempt to show how spread out the data are from the center. They're both awfully important. Okay. You'll see as we go along, we'll introduce examples and you'll see, oh, now we understand why this is so important. All right. Now, by the way, we did mention briefly in the first session that data can come from one of two sources, populations and samples. The majority of the time, we'll be using samples because it's quicker and it's easier, but we do have to be careful to choose our samples wisely. Okay, if we pick bad samples, the results will not be very helpful. Let me just quickly set this up. So in other words, just a quick reminder, a population is a set of measures that are of interest. For example, the ages of all Americans could be considered a population. Whereas a sample is formally defined as a subset or a smaller part of a population. Samples are often used instead of populations because drawing samples is quicker and cheaper than analyzing an entire population. So statistical measures, such as we're looking at measures of location and variability, can be defined for both populations and samples. So whenever we construct these measures, we have to make it very clear which one we're referring to. So if you see a number, you have to be told, is this a population measure or is it a sample measure? Because it matters a great deal. Now, in terms of definitions, statistical measures taken from samples are known as statistics. There's that word, statistics. Statistical measures taken from populations are known as parameters. And then when we have a statistical the last definition here is the concept of the estimator. A sample statistic is known as an estimator of a population parameter. And the word estimator means refers to a formula. Okay, notice it's a formula that we're going to use to generate a number that represents what we think is happening in the population. So yeah, this, in statistics, we do have some terminology that we have to get used to, but not a whole lot. It won't ever really become overwhelming, I don't think. But every new chapter, there's probably going to be a handful of new definitions that we have to learn. Once we've done that, the rest is all just calculations. Okay, so in other words, this sounds very abstract at the moment, but we'll get used to it very, very quickly. Plus, I know you're eager to get started in the calculations. Okay. So now look at all these measures. Now, every one of these has its own purpose. There are different circumstances under which each one of these makes the most sense. So part of the challenge here is to know when to use which one. What are the advantages of each one? What are the disadvantages of each one? And of course, how to actually calculate them. So, well, I guess we'll just get started. Now, I do want to point out one thing as we go along. In statistics, it's very normal for the same concept to have multiple names that mean the same thing. It's not rare at all that the same concept has two or three different names. And this is one of those cases. I just want to mention here that the word mean in this case is the same thing as average. Okay, so don't be confused by that. It doesn't mean like a person who's not very nice. The word mean in this context means average. Okay. So the mean we'll start with, this is the one you hear about the most often. You know, when you're looking at statistical results, when you're reading, let's say on the internet about something or other, some kind of analysis, the word mean is almost certainly going to come up. It's the average is one of the more important details about any data set. So the mean is the center of the location, center of the data. Okay, so let's see, what would be a good example of this? Imagine you had a group where the ages are distributed like this. Now, this is just meant to be a rough idea. This is not exact, but suppose that a sample contains the following ages. You got a 28-year-old, a 29-year-old, 31, 32, 35, 39, 41, 45, 50, 60, 70. Well, so in other words, an average means literally what it sounds like. You're just going to add them up and divide by the number of observations. So of course I just made up these numbers. All right, now there's 10 of them. Let me just quickly pop this into my calculator. So the average turns out to be 39. This is the result of adding up the ages and dividing by 10, since there are 10 people in the sample. But what I want you to notice is that the 39 it's roughly in the middle. Like, in other words, it's right there, right towards the center. It may not be precisely in the center, but it is in there somewhere. So in other words, the majority of the people, roughly half the people are younger than that, and roughly half of them are older than that. So the average is 39. And this is an important piece of information. Now, here's a quick example when you might find this very useful. Suppose an investor buys a share of stock and the rates of return over the last 5 years are, and let's just say that one year he lost 10%, and then the next year made 12%, and then made 8, 15, and then 10. Now, I'm the investor. I want to know how I'm doing with this stock. What is my average rate of return? So I'll add them up. All right, whatever that is, let me just quickly throw them in the calculator. So it's 35 over 5, 7%. So on average, I made 7% per year over this 5-year time frame. And so you can see how awfully important this is. That way I can say, well, listen, there's this other stock out there that on average brought in 8%. Maybe I should have bought that one, or maybe I should buy it now. Maybe I should sell this stock. But I understand how, on average, how much the value of the stock goes up. So we think of this as a measure of central location right here. You can see why, I hope, from this graph. In the sense that the 39 is very close to the center if it's not actually in the center. And it is simply an average of all the data values. And now here we're going to introduce some new notation. I think they didn't mention this earlier, I don't think, but because our measures are defined for both samples and populations, we'll often use different notation to represent them. So here's how this is going to work. X with a little bar on top of that, which is, we'll pronounce this X bar, is the sample mean. Now, for the population, we'll use this symbol, which happens to be the Greek letter mu. So as a rule of thumb, sample measures are represented with Roman letters, which is our alphabet, by the way, and population measures are represented with Greek letters. That's the convention, okay? So that's how you can tell them apart, right? So here, the X bar is the sample mean, and mu is the population mean. And they're mentioning here that X bar is therefore a point estimator of mu, meaning we're using it as an estimate of what's actually happening in the entire population. Like up here, for example, if these people were randomly chosen from a mall, let's say in Westchester, possibly this was meant to be a study on the average age of the people who live in Westchester. It's a sample. The average is 39, so we're going to use that and conclude that the average age in the entire county is probably right around 39. Okay. And the formula, we have a formula, our first formula. Now this is a huge deal right here. So there's some interesting information here. So by the way, sometimes you see this written like this. So what is this all about? Well, N is the sample size. Xi is going to be thought of as the ith element in the sample. So if we come back here and revisit this sample, we can think of this as X1, X2, X3, X4, and X5. So they're all numbered, okay? I is an index. And then we save the best for last. This is the Greek letter sigma, and it is used in math as what we will call the summation operator. So it tells me to add something up. So in other words, when you see something like this, it just says take all n elements in your sample and add them up. That's all it means. So finally then, what this is telling us is that the sample mean is the sum of the elements in the sample divided by the sample size. Now, intuitively, I think everybody already knew that. You know, if I'd asked you to calculate the average um, time that it takes you to get to school every day over the past month, okay, you would have went back 30 days and added up the commuting times and then divided by 30. Okay, so intuitively, I think everyone understands how an average or mean works, and that's what we're seeing here. So that's all they're telling us, okay? Now, it turns out that the population mean has almost an identical formula. And it does. It's the same exact formula. The only difference is that we are being told that this represents the population mean as opposed to the sample mean. The process is the same. It's a sum of population elements over the sample size. Okay, that's it. So which makes perfect sense, I'm thinking. Well, all right then. So so now this spreadsheet, we're going to do this in Excel, by the way. If you go into chapter 3 in Blackboard, I just realized I didn't open it up before we started. Let me go find that. Uh, I guess I closed it down. All right, let me go open it back up again. So this is chapter 3, remember. I guess this is, I'm not sure if this is the right one. Hold on one second. Monthly salaries. Yeah, you know what I just realized? I think I somehow neglected to post this one, so I'm going to go take care of that right now because we're going to need it. Of course we are. Whoop, that's not where it is. There it is, starting salaries. Beautiful. All right, so I'll pop that in there right now, and then we can run and we can do our examples. There we go. All right, so let's get this thing open and then we'll see what we've got. So you can see it's very simple. I mean, it's just got 12 graduates, recent graduates, and their monthly starting salaries. And we're going to do some interesting analysis with it. Now, we may not necessarily be doing any more graphs, but instead we'll be focusing our attention on the numerical methods that we'll be learning in chapter 3. All right. So this certainly saves us a lot of typing, that's for sure. All right, let's give it a minute to wake up. Yeah, it does this to me every so often. I don't know what that's all about. We'll just try it again. All right. All right, so there we are, the salaries. What do we want to do with this information? All right, let's see. Oh, well, we'll start with the average. Okay, great. Now, okay, so it doesn't, then maybe at the end they'll give us some Excel commands. Let me show you how you do in Excel. First of all, I'm going to label this so that, later on I won't come back and say, what is that supposed to be? Now, I can do this in one of two equivalent ways. I can either say, well, listen, add up all these cells and divide by 12. Or I'll put this one over here. Excel has its own command for mean, but it's called average. And of course, you'll end up with the same thing. Okay, so in a case like this, you have an option. Do it algebraically yourself or use Excel's built-in commands. Now, there will be other cases, though, where you really have to use the Excel commands. On the calculator, you see, now this is one of those cases where it's a good thing you have the Excel, because you could do this in the calculator. You would just add up all 12 of those numbers and divide by 12. But that's a lot of work, and there's a lot of opportunities for mistakes. So that means that an average in this group, the starting salary was $59.40 per month. Now, if you remember, if you go back to the beginning of this chapter, there's a list here of the measures of location that we'll be interested in. So we're basically done analyzing the mean for the time being. Now we're going to turn our attention to something called the median. So the median is a little bit trickier to deal with, but it does have a lot of advantages. Okay, so now we're going to introduce the median. So the median is the value at which half the data are equal to or less than the median, half the data are greater than or equal to the median. So as an example, suppose that you earned a 72 on a midterm and you were told that this is the median score. Then half of the class earned a 72 or less, and half of the class earned a 72 or more. So that's not that great. You're right smack in the center. Oh, whatever. You sometimes these things happen, but or sometimes you hear incomes being described in terms of medians. So let's say, for example, suppose that in the United States, the median household income is, let's say, $80,000. This means, of course, that 50% or half of the households in the US have an income of 80,000 or less, and half have an income of 80,000 or more. All right. So yeah, the household incomes are often reported as a median rather than a mean. We'll discuss the reasons for that later on. So it's an important number. And so in order to calculate the median, though, there's one tricky part. So by the way, in these notes, the words data set will be used to represent either a sample or a population. If we're specifically talking about a sample, we'll say so. If it's specifically a population, we'll say so. The words data set can be either. So in order to compute the median of a data set, it is first necessary to sort the data from low to high. Okay. So let's say we go back here and visit these rates of return. So to compute the median return from the stock, the data must be sorted. And then you would get minus 10, 8, 12, 15. Oops, I missed the 10. Okay. And now the median is the value in the center, which is the 10%. Right there. Okay, now that was very straightforward. Now there's just one potential problem though. If the data contain an even number of observations, this approach won't work. Suppose, for example, there are 6 years worth of returns. And the sort of data are, let's say, 8%, minus 4%, 3%, 5, 7, 9, and 11. So this time there's 6 observations. We can't find a single value in the center of the data. Instead, as a compromise, we average out the 2 middle observations, which would be these 2. So in other words, in this case, the median would be the average of 5 and 7%, meaning so there's only 2 cases we might run into: an odd number of values where we look right in the middle, an even number of values where we average out the 2 in the center. So that makes things easier for us. So I would like to point out here, note, there is no formula for the median. It is a procedure. And secondly, the procedure is identical for samples and populations. So you notice I didn't write down any symbols or anything like that because it's a process. It's not a formula. Okay, now we can go ahead and calculate the median. Now in Excel, we don't have to bother averaging out or sorting the data. It can take care of it for us. In other words, let's go back to our starting salaries. And I don't know why it's refusing to open. There we go. And we'll just literally, the formula is median. Select all the numbers you have in your sample. And it is indeed 5905. Now we could confirm this by sorting these out. Here's how you do that. The command you need, or the up here, the function you need is found under data, sort. Make sure you click on my data has headers, otherwise it'll try to include that header in your sorting. And by monthly starting salary, we're going to sort in the cell values. Let's do the smallest to the highest. And there's 12 observations. So we're going to find the average of these two. So the median is the average of 5820. Was that 58? No, it was 5890. Okay. I'll tell it. Let's write it down here so our view isn't blocked. 5890 plus 5920 over 2. And it's the same because that's exactly what Excel did. Okay. So halfway between these 2 points is 5905. And that means that half the salaries are equal to or below 5905. Half of the starting salaries are greater than or equal to 5905. And that's what it means to be the median. All right. Now, I think we may have time. The next measure in our list is, oh, okay. I didn't realize this was still here. Sometimes, you might think that there might be values in your data set that are unrealistic or they're very different from the rest. So you might want to do is chop out the largest X% and the smallest X% because you believe that the rest of them are much more meaningful representations of your data. In that case, we call it a trimmed mean. So we're not going to do that here, but just be aware that there is such a thing. And then the mode, now the mode is probably the least important of all these measures. It's not terribly useful with numerical measure data, but all it is the most common observation in your sample or data population. Now, the weird thing about the mode is that in order to find the mode, you have to sort the data from low to high. And let's say, for example, suppose that the, you know what, I think maybe we could use one of these examples again. How about this one? But I'm going to change it slightly. And you'll see right away what I'm doing. There's 235s. No other numbers are repeated. Since there are more, 35s than any other value in the sample. The mode is 35. I mean, it's just that simple. Now, here's where it gets a little strange. A data set may not have a mode at all. It also can have two or more modes. Oh my God. So let's say, for example, these stock returns do not have a mode because none of them are repeated. But these ages, let's say our ages are now this. Wow. Is that possible? Of course it is. That means here the mode is both 31 and 35. Oh my God. So this data is said to be bimodal because it has two modes. Okay, so the mode is the only measure of location that can have no value or two or more values. That is one of the things that makes it very unusual. But interpreting the mode can be very difficult and is often not used with quantitative data. You can see why it would be helpful with qualitative data. For example, imagine that Apple does a survey of its customers' preferred colors for the iPhone, that is. So, you know, they'll gather up all the information and you'll have a sample consists of, you know, you've got black, red, black, gold, silver, black, black, and then blue, let's say. So clearly in this case, there's three blacks compared to, there's no other that have, oh, there's actually four of them. Okay. And none of the others are repeated. So here, the mode is black. And the company will certainly produce this color for the next iPhone. They have to be crazy not to. Okay, so you can see, yeah, the mode could be very helpful with these non-quantitative situations, but it's not going to be quite as helpful. Here's another good example. Suppose that the grades in a class are whoops. Well, it should be pretty clear that this is bimodal data because there's a tie for first place here. In other words, the two modes are C and A. Okay. You do some classes you tend to run into that. Some classes the grades are very, you know, more evenly distributed, but anyway, so that's the mode. And oh, and just like with the median, there is no formula for the mode, and it is identical for samples, and populations. Okay, so you notice there's no formula in there because there isn't one. It's a procedure. And so, oh, yes, so we forgot to check that out with our salaries. Now, by the way, I think we're going to continue using the salaries for our next session. So I'll just hang on to this. And so Excel has a mode function, but now here's the bizarre part. If you think there might be multiple modes, you need to use the command mode mult, because otherwise it'll only show you one of them. So, well, it worked out just fine because the mode is 5880. But let's just say you had something like this. I just want to see, they only just added this very recently, by the way. They do constantly work, Excel is constantly being upgraded, and they're always adding new goodies to it. Well, it's a very competitive market. What if I add another 5940 here? So you've got two modes, two 5880s and two 5940s. I'm going to see what it does. Well, there you go. It found them both. That's pretty impressive. Well, those guys at Microsoft are constantly working on this stuff. Oh, there's all kinds of new goodies. They've got this Copilot thing up here. They're constantly begging you to use it. It's some kind of AI thing, which I haven't really learned yet. But yeah, they're always trying to upgrade Excel and make it the best package in the world. All right, so as you can see, we got plenty more of these measures. And so, all right, I think this is a good place to stop. A weighted mean is something we use for special circumstances. So we'll save this for next time. It's awfully important. I don't want to rush through it. So for now, we have our first introduction to measures of location. This is going to take up some time, some serious time, but it's awfully, awfully important. So um, I'll see you all next time.